So we have section, or day 3, I guess. Not really a section. So we're on unit, that's me. I am. I'm blended.
I'm blended.
I think the stripes match the pants. My socks are a little goofy.
You love silly socks.
I got Spam socks on and a calf sleeve. I had a cramp yesterday while I was running. That's horrible. I was like 1.5 miles away from the school. My calf cramped up. That I couldn't get it to go away. You can't really run when you have a cramp going on in your leg. It was a long walk back to the school. Running? Having what? Nah. Yeah, but look what you get to end your day on. You get to end your day on with me. How much better could that get? Having 2 days times in a row?
Well, at least you're not Miss Wizard. Yeah.
Oh.
No, I can say Winter. I like Wizard.
So we've got day 3, average rate of change, which is probably terms at some point in your lives you've heard, one would think. Because another word for average rate of change is slope. And so we're going to work on finding slope today, but when you've looked at slope in the past, you've looked at finding the slope of a line, which is really what we're going to do, but we're going to look at it. Average rate of change happens on like curves or through intervals. So if we have a parabola, and I want to talk about the average rate of change, we don't say the slope of a parabola, we say the average rate of change, because we're going to look at intervals, say that this is when x is equal to 1, and say that this is when x is equal to, 4 or something. We want to be able to find the slope of this line, which would be then their average rate of change of that parabola. Now, the nice thing about it is when we're talking about average rate of change is still going to be your rise over your run, just like it was before. That's what slope is. It's rise over run. We've also defined that as the change in y over the change in x. Just another way to say it. How much is my y value changed over how much is my x value changed? Or, the way you mostly see it, y1 minus y2 over x1 minus x2. Or y2 minus y1 over x2 minus x1. It's the same thing. Okay? It's finding the slope of two lines if you're given 2 points. So just kind of a quick reminder, if you're given 2 points, let's say we're given the point 3,4 and we're given the point 6,8, and we want to find the slope of this or the average rate of change of this. Mathematically, it's the change in our y's. So that's 4 minus 8, y1 minus y2, over the change in the x values, x1 minus x2. And then you reduce that. So that's -4 over -3. A negative divided by a negative is a positive. So we would just make that 4 over 3. Which means on a graph, if you've got those 2 points, it means you're going up 4 and you're going over 3 to create that next point within that graph. And that's what average rate of change is. Now, the big change for today is really how we look at these. And one of the ways that we can look at these is we can look at finding the average rate of change, the slope, over given intervals. Now, when we're finding average rate of change over given intervals, you have to understand a couple things. That if we're going to find the average rate of change over the interval 2, 5, that means that I'm going to find the average rate of change from there to here. And I'm going to try to figure out what that slope is, the average rate or slope between those two intervals. So in order to do this, we need to have points. We want to have points. So we're given our x values already. Our x values for this first one are just whatever your intervals are. Those are your x values. So my x value is going to be 2, and my x value is going to be 5. Now we have to find what the y value is that associates with that. And we do this just like we did the other day on Monday. On Monday, you had to find something like f of 2. We said what that meant that we did, if we were finding f of 2, and why I picked f of 2 is because that's 2 right there. When we found f of 2, what we had to do is we started at the origin. We went over 2 spots because my x value or my input was 2, and we wanted to figure out what the output would be. And the output is right there. So that's the point I want to name. So that's the point 2, 3. So now I have one of my points on my graph. One of my points on my graph is going to be 2, 3. The other one we have to find then is we have to find f of 5. So that was equal to 3. We have to find f of 5. So when my x value is 5, what is my y value going to be? Well, it's that point right there. And that's the point 5, 7. So now I've got these 2 points sitting there. So now we want to find the slope of that line because that's our average rate of change. Now, mathematically, it's the change in y over the change in x. So just like we just did, it's going to be 3 minus 7 over 2 minus 5. 3 minus 7 is negative 4. 2 minus 5 is negative 3. So the average rate of change for the interval from 2 to 5, the average rate of change in that is 4/3. Essentially means that I'm going up 4, 1, well, let's do this, 1, 2, 3, 4, and over 3 to have another point on my graph. So that's up 4 over 3. And it's in the positive direction. Okay, so there's the first one. Okay, so now that we've got the first one taken care of, now we're going to find the average rate of change for 1, 3. So again, it's an interval. It's the interval from 1 to 3 that we want to find the average rate of change for. Well, now, really, if you do it like I just did it, just draw those interval vertical lines, you can see it's that point right there, and it's that point right there. Those points are on the graph, so we can use those points. Again, if you don't want to do that, we find f of 1. Over 1, you go up 5. So one of my coordinates is 1, 5. My other x value that I have to use is I have to use 3. So we have to find f of 3. F of 3, it's 3, 1. So there's my other point. My x value is 3, my y value is 1. Now we find the slope. Y's, 5 minus 1. X's, 1 minus 3. 5 minus 1 is 4. 1 minus 3 is negative 2. 4 divided by negative 2 is negative 2. That's the slope. If you look at it, Down 4, 1, 2, 3, 4, over 2. There's the line that I'm looking for my average rate of change. Okay. Questions with those two? All right, now let's look at the third one then. Wow, that came back. That was cool. 4, 7. Okay, so I know my x values are 4 and 7. So I have to find f of 4. Over 4. Boom, 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 boom. It's right there. I think that's the 0.44. So f of 4 is 4, so I've got the 0.44. 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So f of oh, wow, cool. So f of 7 was 3. So we're looking for the average rate of change of that line. 4 minus 3, 4 minus 3, 4 minus 7, 1 over negative 3. Not that bad, is it? If you're given the graphs, it's not too bad. Questions with those examples? Let's look at this one. So you are going to do this one. Go ahead and find the average rate of change in that graph over the interval from 1 to 4. Go, Gadget, go.
What is that from?
So if my x value is 1, what's my y value? 0. If my x value is 4, my y value is 3. So we go with the y's. So 0 minus 3, and then 1 minus 4. So that's negative 3 over negative 3. So 1. Again, we're essentially looking for the slope of that line right there. Can you find the average rate of change given a graph and an interval? Not too bad, right? Okay, so now what if we're given a function? Pretend none of this exists. Weird. So let's say that we want to find the average rate of change now for a function that we don't have the graph for. So in this case, we've got f of x is equal to 3x plus 5. And we're going to find this average rate of change over the interval from negative 2 to 5. So if we think about what we just got done doing, we still know the x values. The x values that we're going to use are those interval pieces. Well, if I know my input is my x value, I can change this from f of x. Now I have an input to put in there. I've got 2 of them. If I find f of negative 2, that's going to give me my y value at negative 2. So anywhere we see an x in the problem, we replace it with negative 2 inside parentheses. We also have to find f of 5. Anywhere we see an x, we replace it with that 5 inside parentheses, and then we solve them. So that gives me negative 6 plus 5, which is negative 1. So if my x value is 2, my f of x or my y value is negative 1. It's 15 plus 5 is 30. Nope. It's 20. It was 30 now both hours. If my input is 5, my output is 20. Now we have the 2 points, just like we had before. So we just have to find the slope. So that's negative 1 minus 20 over negative 2 minus 5. That's negative 21 over negative 7, which is 3. It's linear. Remember, if we have something in the form y is equal to mx plus b, that part out in front of the x is our slope. Yeah. It's kind of, it works. Okay. So the average rate of change of this one is just going to be negative 2. But obviously not going to have things that aren't linear all the time. So let's look at this one. So f of x is equal to x squared plus 5x. We're going to look at this over the interval from 1 to 6. So I know my x values. My input values are going to be 1 and 6. Go ahead and see if you can find the output values first. Find f of 1, and then find f of 6. And then if you want to stop because you're not completely confident, stop, and we'll go over this in about 30 seconds. Okay, f of 1. Inside parentheses, we put a 1. So 1 squared plus 5 times 1. Those have to be the ugliest shoes ever. Why would anybody? This shoe just dropped at Nike. It's got to be the ugliest shoe ever. If anybody has bought this shoe, I apologize. But it's got to be the ugliest shoe ever.
They make ugly shoes now because the trend.
Yeah.
I don't know who made it. I don't think it was.
Sorry, that was really random. So that's 1 plus 5, so that's 6. So you should have the point 1, 6. And then if it's 6, that's 6 squared plus 5 times 6. So 36 plus 30, 66. So there's your 2 points. Now we have to find the slope, the average rate of change. So we're going to go 6 minus 66. And again, I'm going this way. We're going up and down. That's really the wrong thing to use. I'm going up and down. I'm not going this way. We're going up and down. Over 1 minus 6. So that's negative 60 over negative 5, which is just 12. So the average rate of change for that is 12. All that makes sense? Pretty straightforward today? Yes? Okay, so you've got your assignments going to be sitting inside of Schoology as you kind of go into that just a little bit. It's inside Schoology. You've got an average rate of change. You should be able to get this done today. There is a answer key in there as well, so you can check your answers. Tomorrow I won't be here as long as it's not lightning and thundering. We have the section meet tomorrow, so I will be gone tomorrow. There will be an activity in here. It's a Desmos activity, those of you that, Desmos is this thing. So one of you will have the document open. That's the instructions. If you want to work with partner, the other person can have the computer open. And then you'll just follow the directions. It'll say something like, type in y is equal to x squared minus 4. So you'll type that in, and that's what that graph would look like. And then they'll say, let's change it to y equals x minus 2 squared minus 4. And then you put that graph in there. And then it'll say, how has it changed? Key to this is looking at the vertexes. This shifted 2 to the right. And that's all you would put. Shifted 2 to the right. And it's going to do other things. It'll say, change the -4 to 8. What has happened to it? Okay? It's just a Desmo activity. We're going to talk more about that on Friday. Don't overly stress about it too much. What you get done, make sure you put both of your names on it and both of you submit it. Only submit one per group. Okay?